motion of system of particle and rotational motion. See, up to chapter number 6, like we have done kinematics. These all are parts of mechanics. We did kinematics, then we did laws of motion, then we did work, energy, and power. All these chapters are about us point masses. In all these chapters, what we study about point mass. Point mass is basically a mass which have no dimensions of its own. Like this point mass doesn't have length, it doesn't have breadth, it doesn't have area. It's just a point. That's a point mass basically. But now we will study, till now we know how to calculate velocity of a point mass. We know how to calculate acceleration of a point mass. We know how to calculate force and energy of a point mass. But now we will study the motion of a rigid body. By definition, rigid body means a body having a definite shape and size. A body which have a definite shape and size is known as rigid body. So rigid body is a body having definite shape and size. So a body having a definite shape and size is known as rigid body. There's one more conditions for a body to be rigid. Like during motion of a rigid body, during motion, separation between two points on rigid body does not change. So if this is a rigid body, if I'm saying that this rigid body is in motion, this rigid body is in motion, and I put 2 points anywhere on the rigid body, this is point A and this is point B, then during motion, the separation between these 2 points will not change. If the separation is not changing, then only you will say that body is rigid. Otherwise, body is not a rigid body. If I take a solid block of iron and I mark 2 points over the block, during the motion of body, the separation between those 2 points will not change. So you can say this is an example of rigid body. But instead of that iron, if I give you water, somehow I mark 2 points on the surface of water. But when the water flows, then the separation between the points will change. So you can't consider water as a rigid body. So that's rigid body. In this chapter, we will study rigid body as well as system of particles. System of particles means a system having more than one point mass. This simply means it's a system having more than one point mass. Now, this system having which have more than one point mass can be further divided into two categories. These system of particles can be further divided into two categories. The system of particle could be discrete. Discrete means you have a system, but particles, this is one particle and another is this. There is separation between the particles. This is known as discrete distribution. But instead of discrete distribution, you can also have continuous distribution. The example of continuous distribution is rigid body. See, if I take a pen, then there is continuous distribution of particles over the pen. If I take a sheet, then there is continuous distribution of particles on the sheet. So this is what we mean by a system of particles. So in this chapter, we will study system of particles that could be discrete or that could be rigid body. In discrete distribution, we usually have finite number of particles. But if you take a continuous distribution, or if you take a rigid body, then the number of particles are not finite. They are rather infinite. Like if I take this pen, I ask you to calculate the number of points over this pen. So the number of points over the pen are simply infinite. You have infinite many points on the pen. So as far as point mass is concerned, point mass can have only one type of motion, and that is known as rectilinear motion. A point mass can either move in straight line or it can move on a curved path or on a circular path. Both are rectilinear motion and translatory motion. A point mass cannot rotate. A point cannot rotate. A point can either travel in a straight line or a point can move on a circular track. But a point can never rotate. But if you take a rigid body, if you take a pen, this pen can move in a straight line. It can even move on a circular path, and this pen can even rotate. So a rigid body can have following types of motions. First, it can have translation, straight line motion basically. Translational motion. Or your rigid body can have rotational motion. When I say translation, so straight line and the motion on a circular path, both are considered in this translation. Or it can have rolling motion. Rolling is basically the combination of translation plus rotation. So in this chapter, first we will start with translational motion of a rigid body, then we will do rotation, and at the end we will combine translation and rotation and we'll study rolling. The next is, so to study translational motion, we start with the concept of center of mass. So in rigid body, you have infinite many masses. Say you have some n number of masses. And I ask you to calculate the velocity of the system. There are two approaches to calculate the velocity. The first approach is calculate velocity of individual mass and then combine. So if you have infinite masses, then calculate velocity of infinite masses and then combine them. This is one approach. There is one more approach which says replace the whole system with a point. This point is the representative of the whole system. It's like in democracy, a representative is chosen who can represent the entire country. This is the representative of the whole system. If I ask you to calculate the velocity of the system, you will tell me, okay, I'm not calculating the velocity of the entire system. I'm just calculating the velocity of this point. And the velocity of this point will be exactly equal to the velocity of the entire system. If I ask you to calculate force on the entire system, then there are two approaches. The first approach is calculate force on individual mass and then add them up. Or you can do one thing, replace the entire system with a point, calculate force on this point, and this point is known as center of mass. And the force on the point will be equal to the force on the entire system. I asked you to calculate kinetic energy of the entire system. You can do two things. You can either calculate kinetic energy of each of the individual mass, then add them up, or you can calculate the kinetic energy of the center of mass. Both the results will match. So what do you think? Which approach is easier? The approach of center of mass. So by center of mass, we are representing the entire system by a single point. the velocity of entire system is equal to the velocity of that single point. The acceleration of the entire system is equal to the acceleration of the single point. And that point is center of mass. So the definition of center mass says point at which entire mass of the system is supposed to be concentrated. So why I'm saying supposed to be concentrated? Because it can happen that the entire center of mass of the system lies outside the system. See examples. If you have a rod, a continuous rod, center of mass of the rod will lie at the center of the rod. Say you have a disc. So the center of mass of the disc will lie at the center of the disc. This is the center of mass of the disc. But instead, this is rod. This is disc. But instead of disc, if I take a ring, say in rod at the center, there is some mass. You can say that center of mass lies within that mass distribution. In the case of disc, at this point you have certain mass. You can say that center of mass lies within the mass distribution of the disc. But if I take ring, the center of mass of the ring is at the center of the ring. Is there anything at the center of the ring?
No, sir.
In ring, mass is distributed only on the circumference. There is nothing inside the ring. So center of mass of a ring is basically lying at a point which have no mass. That's why I'm saying is a point at which entire mass of the system is supposed to be concentrated. Center of mass can even lie outside the system. The center of mass of the system can even lie outside the system. Then there is one more definition. Yes, Fazil, center of mass of the ring is at the center. Now this is the definition of center of mass. Why we use center of mass? The concept of center of mass, we use concept of center of mass to study motion of system of particles. So if you have a system having n particles, then its motion can be studied using this concept of center of mass. Or which type of motion? Translational motion. Straight line motion. So concept of center of mass doesn't help in rotation. It only helps in translational motion. Now, so this is center of mass. So center of mass is just a point. Next, we will calculate terms associated with center of mass. Terms associated with center of mass means first we will calculate the position of center of mass, that where is exactly center of mass. Second, we will calculate the velocity of center of mass. Then acceleration, force, momentum, and energy of center of mass. Of system having n particles. So center of mass is just a point at which you can suppose that entire mass of the system is concentrated. This is the point through which you can replace your entire system. Now, so the first thing is, how would you calculate the position of center of mass? If you have a system having n particles, then how will you decide where the center of mass of the system is? So for this, you have simple relations. This is x-axis. This is y-axis. This is particle of mass m1. This is mass m1. This is the position of mass m2. This is the position of mass m. This is m2 and this is mn. And this is the origin of the system. So the position of first mass m1 with respect to origin is r1. Position of another mass m2 with respect to origin is r2. Position is another mass mn with respect to origin is r. So you have n masses having position vector r1, r2 and rn with respect to origin. r1, r2, rn be position vector of n particles. Next, we have to locate the position of center of mass. So center of mass of the system will lie somewhere in between these masses. Let's say center of mass is lying here. If center of mass is here, then from the origin, the position vector of the center of mass is r. This capital R is the position vector of center of mass. Position vector means separation of this point, center of mass, from the origin. So position vector of center of mass is it's m1 r1 plus m2 r2 up to mn rn divided by the total mass m1 plus m2 up to m. Now this m1 plus m2 up to mn is basically capital M. I will write this as capital M, which is total mass of the system. So this is the position of center of mass. But if you have position vector, they can also calculate the coordinates of center of mass. Let's say the coordinate of first point is x1, y1, z1. With respect to origin, its x coordinate is x1, y coordinate is y1, z coordinate is z1. In the same way here, the coordinates are x2, y2, z2. Here, the coordinates are xn, yn, z. As far as center of mass is concerned, the coordinates are x, y, and z. I'm representing the coordinate of center of mass by capital X, capital Y, capital Z. So if you want to calculate the x coordinate of center of mass, x coordinate of center of mass, x. So it's m1 x1, m2 x2, mn xn, m1 plus m2 up to m. This is the x coordinate of center of mass. Or you can write this as this is mi xi I is equal to 1 to n divided by the total mass of the system. This is the x coordinate. Now, the same way, just like x coordinates, you can calculate the y coordinate of center of mass. I'm writing it here. The y coordinate of center of mass is m1 y1 plus m2 y2. It's mn yn divided by m1 plus m2 up to m. This you can write as summation of mi yi divided by total mass. I is equal to 1 to m. In the same way, the z coordinate of center of mass is m1 y1 m2 y2 mn yn by m1 plus m2 up to mn. So that's basically summation of, sorry, set coordinates. M1 Z1 plus M2 Z2 up to Mn Zn divided by M1 plus F2 up to M. Or you can write this as, this is summation of Mi Zi. I is from 1 to n divided by the total mass of the system. This is the Z coordinate of center of mass and this is the Y coordinate of center of mass. So I'm giving you a very simple system. 3-point masses on each vortex we have one mass. So this is mass of 1 kg. This is mass of 2 kg. This is mass of 3 kg. Each side of the triangle is. This is your system. So you have to calculate the position of center of mass of the system. So listen one thing, the position of the coordinate of center of mass depends upon the choice of origin. Usually in a question, the choice of origin is given. If the choice of origin is not given, then you will have 3 different answers with respect to 3 different origin. If say Fazil take 1 kg as origin, then the answer would be different. If Noor takes 2 kg as the origin, then coordinates would be different. If Sania says no, I'm taking 3 kg as the origin, then answer would be different. Answer depends upon the choice of origin. Because we are calculating coordinates. Coordinates depends on the choice of origin. So here the origin is given that 1 kg is the origin. So if 1 kg is origin, the coordinates of 1 kg are 0, 0, a comma 0. Okay, Zania, what is the x coordinate of 3 kg? Just tell me x coordinate. I will ask a y coordinate from someone else. What's the x coordinate? If this is 3 kg, I am dropping a perpendicular here. This is the x coordinate, right?
Yes.
How much is this thing? This whole is a, and it's an equal.
A
How much is this?
equal to A minus A by 2.
This is triangle, huh? This side is a. If I am dropping a perpendicular, then perpendicular will divide this side into 2 equal parts, huh? This one,
Yeah.
right?
Yeah.
So x coordinate, how much is x coordinate?
A by 2.
How much is this y coordinate? Fazil, can you tell me how much is this y3 in terms of a?
Yeah, sir, we can apply the trigonometric functions, right, for
Yeah,
finding y2.
right, right. We can apply trigonometric function. Let's say this angle is 60 degree. So we can calculate tan 60 here. How much is tan 60? Tan 60 is this perpendicular upon base. So it will be y3 divided by base, which is a by 2. Tan 60 is root 3. Root 3 is y3 by a by 2. So you can write your y3 as a by 2 root 3. Clear? So this is your y coordinate, a by 2 root 3. Sania, coordinates means length, not mass. So if I'm asking the x coordinate and y coordinate of this point, that means the separation of this point from the origin. This point lies at the origin. So the coordinates are 0, 0. If I'm asking x and y coordinates of this point, that means this separation from the origin along x-axis and the separation from the origin along y-axis. Since point lie on the x-axis, so y coordinate is 0. The coordinates of this point means separation of this point from the origin along x-axis. This is the x coordinate. From the origin, from y-axis, this is the y coordinate. Now after this, try to calculate x and y coordinate of center of mass using this relation. Like x coordinate of center of mass is just m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. And can also calculate y coordinate of center of mass, which is m1 y1 plus m2 y2 m3 y3 over m1 plus m2 plus m3. So that is your m1, this is your m2, and this is your m3. It's 1 into 0 plus 2 into a plus 3 into a by 2. So x is 2a by 3. Let's check. 1 plus 2 plus 3. So that's 2a plus 3a by 2. So that's 4a, 7a by 2 into 6. Sania, you're making mistakes even in addition. It's 2a, 3a by 2, 4a, 5, 6, 7, 7a by 2 into 12. So that's 7a by 12. And y is m1, y1. So m1 is 1, y1 is 0. m2 is 2, y2 is 0. m3 is 3, y3 is a by 2 root 3 over 1 plus 2 plus 3. So this is 3 root 3 a by 2 by 6. So it's 3, 2. It's root 3 by 4a. Next. The next thing is some few conceptual questions. If you have two masses which are equal, let's say there are two masses, they are placed at a separation A, then their center of mass will lie exactly at the midpoint. Means this will be a by 2 and this will be a by 2. So center of mass of two equal masses will lie at their center. So if you have two equal masses, the center of mass will lie at the center of the system. But if masses are not equal, this is m1, this is m2. If I say that m1 is greater than m2, then center of mass will lie near the heavier mass. This you can easily calculate by considering one of them at the origin. But these are conceptual questions. You can remember these things directly. That center of mass of a system having two unequal masses will lie near the heavier mass. So center of mass of system having two unequal masses will lie near heavier mass. So center of mass will lie near the heavier mass. Okay, just note it down. Okay, can you guess the where the center of mass of Earth Moon system will lie?
Closer to the Earth.
Earth.
Earth Moon system. Will lie. Where it will lie? Near the moon or near Earth?
Earth.
Near the Earth.
Earth. Near.
Very close to Earth. It lies so close to Earth that it seems like moon is revolving around the Earth. Actually, moon is not revolving around the Earth. Moon is revolving about the center of mass of Earth and moon system. The mass of Earth is very high as compared to the mass of moon. So the center of mass lies very close to the moon. It seems like the center of mass of the Earth moon system is lying itself on the surface of Earth. So if moon is revolving about their common center of mass, so it seems like that moon is revolving around the Earth. But actually moon is revolving about the center of mass of the Earth moon system. Similarly, if you take center of mass of Earth and the sun, then sun is very heavy as compared to Earth. So the center of mass of sun and Earth system lies very close to the sun. So actually sun Earth is not revolving around sun. Earth is revolving around the center of mass of Earth and Sun system. But since that center of mass lies very close to Sun, so it seems like that Earth is revolving around the Sun. Remember these discussions. These are you may need this thing in your conceptual questions. So that was about center of mass of discrete particles. You are having n discrete particles. But instead of discrete particles, if you have rigid bodies, center of mass of rigid bodies. By rigid bodies, we mean like you can have a rod, you can have a disc, you can have a ring. If you have a rigid body, then the number of particles, okay, what do you think? The number of particles in a rigid body is the number of point mass particles in a rigid body are finite or infinite? Yes, what do you think? If I take a rigid body, then the number of point masses in that rigid body is finite or infinite?
Infinite.
Infinite.
Infinite. If I take a pen, it's a rigid body, and I start counting the number of points on the point, the number of points are infinite. So a rigid body can have infinite point masses. It actually have infinite point masses. So you cannot add up to infinity. When you have infinite particles or infinite things to add or combine, then instead of addition, we usually prefer integration. So for a rigid body, to calculate x coordinate of center of mass, we don't add, we basically integrate. And then I divide it by total mass. This total of mass can also be calculated in this way. This is integral of d. So instead of addition, you will use integration. Similarly, you can write expressions for y coordinate, z coordinate of center of mass. Y coordinate of center of mass is integral of y dm by total mass of the body. It's integral of y dm by integral of d. That is the y coordinate of center of mass. Z coordinate of center of mass is integral of z dm over total mass of the system. That is the z coordinate of center of mass. So this is how we calculate x, y, and z coordinates of the center of mass. So let's do one example on this concept. Let's calculate center of mass of a rod of length L and mass M. So rod is discrete distribution of particles, or is it or it's a rigid body? Yes, rod is discrete distribution or it's a rigid body?
Rigid.
Rigid.
It's a rigid body. When I say rod, that means I am considering a system which is one dimensional. Means the thickness of the rod is negligible as compared to its length. So while considering rod, I'm not considering the thickness of the rod. Its thickness is negligible as compared to its length. So this is the length of the rod and this is the mass of the rod. Let's take this point as origin. First of all, to calculate position center of mass, I consider an origin. Then consider a small element. Take mass of this small element as dm and length of this small element as dx. The separation of this small element from the origin is x. This is the separation of small element from the origin. So consider a small element of mass dm, length dx at a separation x from the origin. So at a separation x from the origin, I consider an element. The mass of the element is dm, the length of the element is dx. So if I use the definition of center of mass, the x coordinate of center of mass is the integral of x dm divided by the total mass. This is it. Now we have to choose proper limit. So this x can lie from the origin to this end. If I start choosing this small dm, then I can choose this dm from the origin to this end of the rod. I cannot choose this dm beyond the rod because dm has to be a small portion of the rod. I cannot choose this dm beyond this origin. This has to be within the length of the rod. So the limit of x will be from the origin to this end. Origin means x is 0. This end means x is 0. So the x coordinate of center of mass comes out to be it's 1 by m. It's 0 to L. It's xt. But this
Yes, sir.
is not solvable. This particular integral is not solvable. There is a problem with this integral. Okay, can you identify what's the problem with this particular integral? There is one major issue with this integral. This is not solvable right now. It's because in an integration, you cannot have two variables. This one is x and another is dm. If you want to integrate x, then instead of dm, you should have dx, right? You should not have dm, you should have dx. But the formula says it should be mass only. So through some mathematical steps, you have to convert this dm in terms of dx. To write this dm in terms of dx, let's see what is dm basically. Dm is the mass of length dx. The mass of the total rod is m. If you look at these four things, like total, the mass of total length is m, and the mass of this length dx is dm. Using these things, you can convert this dm in terms of dx. You can use unitary method basically. See, mass of length L is equal to m. This is the mass of length m. Mass of unit length. So what's the mass of unit length? Mass of unit length is simply m by L. Next, you need mass of dx length. So how much is the mass of dx length? It's mass per unit length multiplied by dx. Mass per unit length multiplied by dx. This is what we call dm. So dm is m by L dx. Is it clear? This dm and the relation between dm and dx.
Yes, sir, it's clear.
I'm just using unitary method. Next, I can substitute 2 in 1. If I substitute 2 in 1, then the x coordinate of center of mass comes out to be it's 1 by m. It's 0 to L. How much is x? It's x. Dm is m by L dx. Now you can take your ml and as constant, take them outside. So it's 1 by m into m by L. It's 0 to L. It's x dx. It's a simple integration. I will not solve this integral. This into. Solve this integral and tell me the answer. What is the value of x? X coordinate of center of mass.
It's x square.
Okay, you didn't substitute the limits.
No.
Why? It's x
By
square.
2 L.
It's 1 by 12. Then it's L square minus 0 square. It's L square by 12. It's L by 2. So the x coordinate of center of mass is L by 2. L by 2 means center of mass lies exactly at the center of the rod. So not just rod. So the center of mass of the rod is lying at the geometrical center of the rod. Not just rod, if you calculate the center of mass of any symmetrical figure, like if you calculate center of mass of a square, it will lie at the center of the square. If you calculate the center of mass of a sphere, it will lie at the center of the sphere. So instead of calculating center of mass of each body, you can simply remember this expression, this thing that center of mass of bodies having regular shape and size will coincide with their geometrical center. So for a body having definite shape and size, center of mass will coincide with their geometrical center. Means if you have a rod, then center of mass will lie at the center of the rod. If you have a disk, then center of mass will lie at the center of the disk. Center of mass will lie at the center of the disk. Instead of rod and disk, say you have a square, then center of mass will lie at the center of the square. So for bodies of all regular shape and sizes, the center of mass will lie at exactly at the geometrical center. So now onwards. So if you have a system having more than one rigid body, say you can have this system. If I gave you this system is you have 3 spheres. So all spheres are identical. All have radius r. This is the sphere number 1, sphere number 2, and sphere number 3. I'm asking you to calculate the center of mass of the system. Calculate position of center of mass of system of spheres. So you have this system having three spheres, just placed one over another. You have to calculate center of mass of the system. If you analyze this problem, then you have to calculate center of mass twice. It's basically a second grade problem. See, you don't have point masses, you have spheres. So first of all, you will calculate the center of mass of the individual spheres. And where is the center of mass of the sphere? Is at the center. So this is the center of mass of the first sphere. This is the center of mass of the second sphere. This is the center of mass of the third sphere. See, all spheres are identical, their masses are n. So that's the first step. First of all, you will replace these spheres by their respective center of masses. Now, how many center of masses you have in your system?
3.
3.
3 center of masses. Now, you will replace each of the sphere by their center of masses and you will calculate a common center of mass of the system. You will calculate common center of mass of all 3 spheres. Let's say that common center of mass lies somewhere. The common center of mass lies somewhere. So to calculate that common center of mass, we'll use the same method. Once you replace these spheres by the point masses, these spheres will behave like a point mass. You have 3 spheres. Or you can say that you have 3 point masses. You have 3 point masses. There's this is like the first numerical on center of mass that we did. You replace each sphere by the center of mass. So you have 3 points. 3 points having the separation. Can you tell me the separation between C1 and C2? They are placed just back to back.
2R.
It's 2R. Similarly, this is 2R. Similarly, this is 2R. So separation between any 2 points is 2R only. And mass of each sphere is n. You can easily calculate the position of center of mass. The position of center of mass is this thing. X coordinate is m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. Okay, so if I take this point as origin, Sania, now I think you can tell me the coordinates of these points. So the coordinates of C2. This is C1 is origin. Sania, what are the coordinates of C2?
2R, comma, C2.
2R, comma,
C2.
0.
No, 0. 0. Sorry.
Next, I need coordinates of this point. See, the x coordinate of this point, x coordinate of this point is R.
R.
On the y coordinate. Y coordinate. Just have calculated y coordinate in the last numerical. How much is
3.
how much?
Root 3 by R.
By R. Okay, just calculate once.
Okay.
Let's do the calculations, right? And tell me what's the y coordinate. Root 3R.
Root 3R.
3R. Good. Okay, now calculate the center of mass of the system. So the x coordinate is simply its mass m, x coordinate of first particle is 0. This is 0. The x coordinate of second mass is m. It's 2m. Mass is m. Its coordinate is r divided by m plus m plus n. So it's 2r. So this is basically 3mr divided by 3m. It gets cancelled out. So the x coordinate of center of mass is equal to r. You can even calculate the y coordinate of center of mass. That's m1 y1 it's m2y2 plus m3y3 by m1 plus m2 plus m3. So the y coordinate of center of mass is m1, which is m, y1, which is 0, m2, which is m, y2, which is 0, m3, which is m, y3, which is root 3r, divided by m plus m plus m. So this is basically m into root 3r over 3. M cancels with this m. And you will get that the y coordinate of center of mass, is r over root 3. Okay. So after this, there's one more type of question. So first understand question, then I will write the language. You have a disk. This is basically given in NCERT. This is a disk. The radius of the disk is r. From this disk, I remove a circular portion of radius r by 2. I remove a circular portion of radius r by 2. So this white means I have removed a circular portion. The radius of the disk is r, and the radius of the circular portion is r by 2. Now I'm supposed to calculate the center of mass of the remaining disk. So from a disk of radius r, remove a circular portion radius r and mass m. A circular portion of radius r by 2. Calculate center of mass of remaining disk. We need to calculate the center of mass of the remaining disk. Now see, instead of removing this disk, consider this as two systems. One system, a complete disk having center of mass as its center. Also consider the disk that you are removing is another disk of some mass m prime, because the mass of the complete disk is m. So the mass of this portion would be somewhat less. I'm taking this as m prime. So consider this system as two disks. A disk of mass m and radius r, and a disk of mass m prime and radius r by 2. So you can write this as that remaining disk is equal to original disk of radius r minus disk of radius r by 2. Fine. So for these type of problems in which from a disk you cut another disk, or from a sphere you cut another sphere, then consider that cutout portion as a body. So you have two bodies here. So the x coordinate of the remaining disk is x coordinate of the original disk minus, or you can say this is x coordinate of remaining disk is m1 into x coordinate of the first disk minus m2 x coordinate of the second disk divided by m1 plus m2. So instead of adding, if you are removing something, then we subtract them. Now, how much is m1? M1 is capital M. I consider this the center of the original disk as the origin. Then how much is x1? X1 is 0. How much is M2? That need to be calculated using unitary method. How much is X2? The center of mass of this disk from origin, the separation is R by 2. Now you just need M by 2. M2 means the mass of the disk that you have removed. So to calculate the mass of this disk, you can do one thing, like mass of the complete disk is M, the radius is R. Okay, tell me one thing. Over the disk, mass is distributed over length, area or volume. For the disk, mass is distributed on the length of the disk, on the area of the disk, or on the volume of the disk.
So area.
Area. Disk is two-dimensional. So you can say that mass of pi r square area is m. You can calculate mass of unit area. That comes out to be m by pi r square. Then you can calculate the mass of this r by 2, this disk of radius r by 2. So pi r by 2 square is m over pi r square multiplied by pi r square by 4. This is what we call m2. Pi to pi cancel. So this m2 is just m by 4. Now, this would be your homework to substitute the values of m1, m2, x1 and x2 here and get the center of mass of the remaining.